Okay, welcome back to my Programming in ARM Assembly video series. Let's just jump back into the code. Okay, so when I left off in the last part, we were generating a random number, but our random number isn't constrained in any way. So I want to add a constraint, essentially. So what I have in mind is to require that before this function gets called, we'll say that R0 will contain some minimum value, like 0 or 1 or whatever, and R1 will contain a maximum value. So that way this random.s file will be a little bit more general purpose. For the sake of the game, I really only want to generate a random number between 1 and 100, but having a way to generate random numbers between two points as just a general purpose would be pretty useful. And actually, with that in mind, I think I want to increase the buffer size. So instead of just getting 1 byte, let's get 4 bytes. That way our range is much bigger. So that's like 32 bits, which is a pretty big range. So let's say that when we come into here, we're going to move into, so I'm going to be overriding registers 1 and 2. So before I do anything, I want to essentially make a backup copy of the registers of register 0 and 1, so I have a copy of min rand and max rand. And I think we can use, let's see, R3, R4. Let's use R3 and R4 for that purpose. So we'll say move into R3, whatever value was in R0, and that is going to be min rand. And then we'll move into R4, whatever value was in R1, and that will be max rand. And before I forget, that means we're going to want to make a backup of those registers, so we need to increase this range from 0. And actually, let me figure that out later, because I'm probably going to be, I'm certain I'll need more registers as well. So for now, temporarily, let's say this is temp. We'll hard code into R3 the immediate value 1, and we'll hard code into value 4 the immediate value 100. That'll be our range. So for now, we won't worry about the main.s passing anything in while we're doing this little bit of work. Okay, so that establishes our boundary. Then we go through our code, we pull out the random number, we close out the file, we recall the random number into register 0. Now we need to do boundary checking on that number. First I'm going to figure out the upper bound, because actually it may be the case, for what I have in mind, it might be the case that working out the upper bound just automatically solves the lower bound as well. So what I have in mind is to I want to count up I want to count the highest bit value that was in the upper bound. So for example, if we have, let's say, a simple number like 8 is that, let's say 8. So in binary, 8 would be in 8 bits, it would be like this. So the highest bit value in the number 8 would be, the 4th bit from the right. And if the number was, like 16, then the highest bit would be the 5th from the right. So that I want to figure that out. I want to figure out what the highest bit is for the max rand, because all bits to the left of that highest bit are 0. So what we can do is we can AND the values together against the random number to automatically zero out all those high bits. And that will guarantee that our max rand or that'll guarantee that our random number is no higher than whatever the highest bit of the left highest one would be. So in the case of, let's say we want to limit our value between 1 and 20. No, let's say we want to limit our value between 1 and 10. So that would require, you can't have the number 10. Actually, let me rethink about that. 20. Let's say 20. You can't store 20 in 4 bits. You can only have up to the value 15. So we would need at least up to the 5th bit to store the value 20, but that also means that that we could potentially store up to whatever that would be, 32 or 31, whatever that would be. But if we're passing in some huge number like 1 million, and we run a bit mask against a 1 million, we've at least narrowed that number down to like 31 or whatever, again, whatever that would be when you add it all up. I think it's 31 or something. And then, so from 31, if we want to limit the number to 20, we only have to reduce it by another 10 or 11 in order to guarantee that it's underneath of that maximum amount. So that's essentially the idea. Hopefully that makes sense. So to do that, we're going to need to do a few things here. So the first thing I'm thinking of is we're going to need to compare max rand against the immediate value 0, because in order to calculate that bit, I want to shift max rand over to the right until the number is equal to 0. And then, but every time I do that, I'm going to keep track of, I'm going to essentially count how many times it was shifted over. And that will tell me, that'll define the bit mask that I'm going to use. Okay, so let's shift to the right R6 by 1 spot, but only if. So if it's once it's equal to 0, once we don't have any bits left, then we're done. So I'll figure out what I want to call that later. And then as we're doing that, I want to add so I need to keep track of some things here. So we'll just say R5 will be our bit mask. And I want to add the number 1 to that, and then I want to shift that over I want to shift that to the left so that eventually I'll end up with a bit field that looks like that. So like in the case of like what I was talking about earlier. Okay, so hang on, let me think this through. So we're going to need to initialize some values here. But let's think about this. So compare, and actually I think I still, I think I might actually need to make a backup copy of max rand. So let me do that. Move into R5, whatever value was stored in R6, because I think I might need to recompare with that later. So backup max rand, and then we'll use we'll use R5 for our bit shifting. Yeah, we'll use R5 for our bit shifting. That way we don't lose the original max rand value. Okay, so let me think. Compare R5 to 0. If it is equal to 0, then we're done with our bit shifting. If it's not equal to 0, then we want to shift it to the right by 1 spot. And every time we do that, we need to, in order for this to do us any good, we also need to have another we'll initialize that to the immediate value 0. This will be our bit mask. So every time we shift that to the right by one spot, we need to add 1 to R4. Yep. But first, we need to shift whatever value is currently in R4 to the left. So shift left by 1, and then add 1 to R4. So if R4 is currently 0, so the first time we go through it, R4 will be 0, and then we shift max ran to the right, we then shift the bit mask to the left, which won't actually accomplish anything the first time we go through it because it'll be 0, and then we add 1. And then the next time we go through it, we'll shift the current 1 to the left, but then we'll add 1 to it. So then we'll basically be going in binary. It would be like 1, 3, 7, 15. That's how the count would be going. And then once that's done, and then we'll need to branch back unconditionally to whatever we're going to call this loop. Do we have any loops in here? Not yet. So we don't have any loops in here yet, so we'll just call this loop. And then since that's kind of inside, we'll move all that over. So we want to branch to loop. Eventually, R5, which is our temporary copy of max rand, will be 0. And then once it's 0, we'll just we'll branch to exit loop, because that's essentially what we want to do. So we'll have this label down here called exit loop, so that we have a way out. Okay, so once we have our bit mask defined, we can then AND together the temporary, not the temporary, but we can AND R0. It doesn't matter which order we do these in because we're ANDing, so it doesn't matter if I'll put R0 first or whatever. So we want to AND R0 together with our bit mask that we just made, which is R4. And when we do that, that will seriously reduce the size of the random number. It won't completely constrain it to our limit. We'll have to do something else after this, but at the very least we've brought the number of choices severely down. So let me think about this. Do we actually need a copy of max randy? I think we do, because currently, because the problem now is that R5 is 0, so we don't know anymore what max rand was if we didn't have that value there. So let's keep that for now. And I think I just want to see kind of what kind of numbers we end up with at this point. But before I go any further, I just want to extend the range here. So we're up to R5 at the moment, R6. So R2, actually it's just going to be 7 at this point. So R2 to R7 are the registers that we want to make sure we don't overwrite. Okay, so hopefully that makes sense. Now let's make, and let's actually just kind of run the game and see make sure that we don't have I think at the moment the highest possible random number we could have would be 127. I think. Or, yeah, I think that's right. I think the highest possible random number we could have right now would be 127. So let's try something way higher than that. So that's too high. So let's try 128. That's too high. I'm pretty sure the number has to be lower than 127. I don't know if it can be negative, though. Oh, God. Oh. Okay, well, it's a work in progress, right? When we and our four, we move it over by 1, then we add 1. You know what? Let me look at this in the debugger. Ye old debugger. All right, so breakpoint 1, and we want to step into, run, and then step into rand and see what's going on. So step, step, step. I just want to get down to that new section and kind of follow the bits. All right, so bit mask will be 0, R4, R5 and R6 should be equal. Wait, R5 is 0. Or rather, R6 is 0 right now. Wait, is it? So that would definitely be a problem if R5 and R. I think I know what I might have done. Let me continue through the end, exit, quit. I think I backed up. Okay, yeah, my bad. So I put max rand in R4. I thought I put it in R6. So this needs, you know what, actually let me just do that then. Wait. I need to make a backup of rand, and it's currently, where is it? So R3 is min, R4 is max. So I need to change these registers around a little bit. So R3 is min. So if I want to make a backup copy of max rand, I need to copy from register 4. So that means that this should probably be register 6. So the bit mask will be 6. And now that's still fine, but now we want to change these to register 6. And then that will be 6. All right, let's do that. Let's remake. Let me just quickly... Okay, and then 200 is too high. 100 too low. So potentially, and again, I think the way this works, it cannot be higher than 127. But it's still possible for it to be over 100. And clearly we can see that it is, because 100 was too low. So let's run that again. So 0 is too low, and I think 127 is as high as it could be. Okay, so it's below 100 on that one. So it's below 100 on that one. Below 100 on that one. It's below 100 on that one. Okay. So it's above 100 on that one. 127 is too high. So I feel like we've definitely constrained it to 0 to 127 at this point. All right, so because of the time, I'm going to go ahead and stop this part here. But when we come back, I want to look at this in the debugger to make sure that what is happening is what I think that I programmed in. All right, so thanks for watching, and I hope to see you in the next part.